All right, we're going to start looking at part 2 of the geometry exam, the 2017 geometry exam. All right, on question 25. And before we start, just want to point out a couple of things. This exam, when you get to part 2, there are 7 questions. Each answer will receive 2 credits. So each one is worth 2 points. And make sure and show all the work that you can. Let's look at the first one. Now, looking here, it says, using a compass and straight edge, construct a line of reflection over which triangle RST reflects onto triangle R prime, S prime, T prime, and leave all construction marks. So here we go. The 2 things you need to do in order to construct a line of reflection, and you need to write this down. You need to connect 2 corresponding points, making a line segment, and then you need to construct the perpendicular bisector of that line segment. And once you do that, that is your line of reflection. So I'm going to go ahead and do that here. Hopefully you have a compass or something like that, but if you do not, just watch this and hopefully get the idea of what I'm doing. All right, so I'm going to get my, first thing I'm going to do, you would want to use a straight edge. So I want to connect 2 of the corresponding points. You could do R to R prime or S to S prime. It doesn't matter which pair you do. Just don't do S to R prime or anything like that. All right, so I'm going to get my compass now. And it's up here. All right, so the perpendicular bisector is the most important construction. It's the one that is used the most, I would say. And what you're going to want to do is put the point of your compass on one of the points, and then bring your compass out more than halfway. And I'm going to draw a circle. Now, keeping the compass the same opening, the same radius, we're going to switch it and put it on the other point. And then to finish it off, we are going to draw a line right through, and that is your line of reflection. All right, and if you're on the test, you might want to point that out. Just write down with an arrow. Just make sure that whoever is reading it knows that you know that this is the line of reflection. All right. So there we go for that. 2 steps, very easy. So that's that. Let's move on. All right, looking at number 26. It says the graph below shows triangle ABC and its image, so the pre-image is ABC, and its image A prime, B prime, C prime. Describe a sequence of rigid motions which would map triangle ABC onto triangle A prime, B prime, C prime. When it says sequence, that means right after each other. All right, so you have to imagine what you can do to move this triangle ABC onto A prime, B prime, C prime. Now, if I'm looking here, it looks like I'm going to have to reflect. Because if I just were to move this entire triangle translation-wise, or do a translation on it, the points would not match up. So maybe I want to translate down and then reflect. Or maybe I want to reflect and then translate down. One of those would work. But when we have rigid motion, I want you to write this down. We have 3 rigid motion transformations. And what rigid motion means is that the new shape will be congruent to the original, or the image will be congruent to the pre-image. And these are our 3. Remember, dilations are not necessarily a rigid motion transformation. They could be congruent when you dilate, but not necessarily. So we don't consider dilations a rigid motion transformation. So I'm just going to do with a marker I'm going to show you what you could do to this shape in order to, that it would land on A prime, B prime, C prime, okay? So if I took this point C, if I took all these points, moved them down, moved them down, moved them down, right? So if I translated them down, so it would be a translation of 0 and then -2. Okay, if you remember this, this means a translation of 0 to the left and or right, it doesn't matter, 0 to the left or right, because you're going 0, and 2 down, right? And then you could reflect it over the y-axis, all right? So just imagine if you have a point A prime here, B prime here, and C prime here, all right? Now, imagine now I reflect it over. Right, remember, reflecting is like folding. So if I fold it, imagine now we have our triangle here. Right? Now if I reflect it over this y-axis, this point would go, imagine me folding also. Imagine me folding. Right? So that's what we can do. So we can translate. So we can translate the original why do I keep spelling original wrong? I don't know. Do it again. The original. There we go. We can translate the original triangle 2 units down and then reflect it over the y-axis. Okay, so that is a sequence of rigid motions which would put triangle ABC, it would map it right onto A double prime, B double prime, C double prime. All right? All right, there we go. Let's move on. All right, number 27. Let's look at what we have here. All right, now we have, let's read what we have here. It says, when instructed to find the length of HJ in right triangle HG or HJG, Alex wrote the equation sine of 28 is equal to HJ over 20, while Marlene wrote cosine of 62 is equal to HJ over 20. Are both students' equations correct? Explain why. All right, you have a right triangle, and both of these students used our sine, cosine, or tangent. That's SOA, CA, TOA. Right? Remember, we have sine, cosine, and tangent. So the first student said, okay, to find HJ, I'm going to do the sine of 28. Remember, this would be my opposite. This would be my hypotenuse, the 20, and this would be my adjacent, based on the 28-degree angle. Based on the 28-degree angle. So what this person did, Alex, that is, when he wrote sine of 28 is equal to the opposite, which is HJ, he just wrote HJ, over the hypotenuse, which is 20. That looks good. Now look what Marlene wrote. She wrote the cosine of 62 is equal to HJ over 20. Now, when you deal with cosine, that's the adjacent over the hypotenuse. Now, where did this 62 come from? Well, if we have a triangle, remember, 180 degrees in a triangle. So if you look at this other angle, you actually can figure it out. And if you do the math, you figure out that it is 62 degrees. Now, if you're looking at this angle, this actually would change the side. So this would actually be my opposite based on the 62-degree angle, and this would be my adjacent. And the cosine of 62 would be the adjacent, which is hj. So the cosine of 62 is equal to hj over 20. So it looks like they're both right. And here's a reason why. All right? And you could write this. Right? When two angles are complementary, complementary means add to 90. Or add up to, maybe more specifically, add up to 90. So when two angles are complementary, that means they add up to 90. And when you know two angles are complementary, the sine and cosine of those angles are equal. So in other words, if A plus B is equal to 90, then sine A is equal to sine, I'll move it back down here. Right? Then sine A is equal to sine B. And A plus B in this case are 62 and 28. Since they're equal to 90, their sine and cosine are going to be the same. Now if you go to a calculator, you can kind of see it. And we did this exercise in class if you were there. If I do the sine of 40, and then I do the cosine of 50, you see how they're equal. Now 40 and 50 add up to 90. It doesn't matter what the angles are. If I did sine of 1, and then I did the cosine of 89, right? They're equal. So if two angles are complementary or add up to 90, that means their sine and cosine are equal. So there we go. That's our reason why. All right? Now, let's go to the next problem. All right, a couple definitions I want you to write down. First, what is a tangent line? You're going to need to know that in this problem. Maybe we should look at the problem first. Let's look at the problem. It says in the diagram below, tangent DA, so this would be our line, our tangent line, and secant DBC are drawn to circle O, that's the center, from an external point, external means on the outside, such that arc AC, that's this arc, is congruent to arc BC. All right, now the question is, if the measure of BC is 152 degrees, determine and state angle, the measure of angle D. All right, so a couple things. First of all, I want you to write the definition of a tangent line, a line that touches a curve at one point. That's what DA is. All right, a secant is a segment that intersects a circle twice. That's what DBC is. All right? And let's see here. We have some information. All right? Let's see. So we have measure of arc BC is 152. So BC, I'm going to label that. So that means this part here is 152 degrees. Now, we also know that AC is congruent to BC. Arc AC is congruent to BC. So if BC is 152, that means that AC is 152 degrees. Now, we know all the way around has to be 360. So you have 152 and 152. That gives you 304. So that means that the rest is going to be 360 minus 304, which is 56. So this is going to be 56 degrees here. Right, that's BA. So this part here. So this arc here, 56. So that's going to help us, hopefully. Maybe it won't, but we like to write down all the information that we can. Now the angle we're looking for is actually this angle right here. Now there's a little formula that I want you to write down, and it's right here. I want you to write this down, and this is numerically what it looks like with our specific letters involved that we're using. Okay, an angle formed by a tangent and a secant. Right, so we have our tangent, which is DA. We have our secant, which is DBC, is equal to 1/2 the difference of the intercepted arcs. So difference means subtract. That's why we have here subtract. Our intercepted arcs are AC, which is this one, and BA, which is this one. These are the two arcs that get intercepted by the tangent and the secant. So we're gonna plug this in now. All right. So the measure of angle D is equal to 1/2 times the measure of arc AC, which is 152, minus the measure of arc BA, which is 56. So the measure of angle D is equal to 1/2. 152 minus 56 is 96, right? 96. And then the measure of angle D is equal to 1/2 of 96, which is 48. So that means that this angle, angle D, is 48 degrees. All right? So there you go. Make sure you wrote down all the notes. And I think that's it for today.